Assalamualaikum warahmatullahi wabarakatuh. My name is Farhana. My metric number is DE183. Okay, the power system stability is used in generator to prevent stability under fault condition. Transient stability analysis is conducted to evaluate the efficiency of PSS under the temporary fault condition. Power system stability is the ability of an electric power system for a given initial operating environment to restore operating equilibrium after being exposed to physical destruction. Type of stability is first one is steady state stability, second one is transit stability, and last one is dynamic stability. PSS need to analyze a power system rotor angle stability during the dynamic transformation. Type of disturbance. First one is sudden widespread load increase, sudden significant load increase, temporary three-phase bound effect, and last one permanent three-phase bound effect. Methodology. First one is single line diagram. This is a simple single line diagram with two area system which consists with two similar areas connected by the weak tile. Each area consists of two coupled units, where each area having rating of 900 MVA and 20 kV.
My name is Nur Faradila Afika binti Hassan. My metric number DE180186, and I will explain to you the process flow of the system. Firstly, the single line diagram of two-area power system was developed using MATLAB Simulink by Brochure de Simulink library. Next, we insert the parameter value given in the laboratory instruction into the single line diagram. After that, apply the value for each component in single line diagram and run the simulation to obtain the graph. If the simulation is success in obtaining the graph, it will move to next step, which is record the result and reading of output graph for rotor speed, rotor angle, the magnitude of voltage and power, and also stability of system. If the simulation is failed, the system needs to be troubleshoot the error by changing the value of parameter on selected bus. Next, the simulation that we use to model the two-area power system is by using a MATLAB Simulink with SimSCAD Electrical.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Suhada binti Zainal Abidin, metric number DE180175. For my part, I will present the result and discussion for case 1 and case 2, which is sudden large increment of load at bus 7 and sudden large decrement of load at bus 7. Okay, firstly, for the sudden large increment of load at bus 7, okay, this is the graph that the simulation that we designed using MATLAB software. As we can see, there is two area, which is area 1 and area 2. Then the sudden large increment is placed at the end of the circuit at area 1. The purpose of the load installation is to observe the ability of power system to remain in equilibrium after the load increase. Okay, firstly, for the graph, there we observe three graphs from here, which is rotor angle, rotor speed, and voltage of the system. From the graph of rotor angle, we can see that firstly, the system was unstable after the large increment, and then after 5 seconds, it starts to achieve the steady state condition. And then for the graph of rotor speed, the speed decreases in entire generator of the system. And the third graph, which is voltage graph, we can see that after the sudden large increment, the graph firstly rising and then it start to achieve its steady state condition. It is because after 3 seconds, the circuit breakers detect the interruption in the system and operate to release the disturbance. Okay, and then we will see the graph for electrical power. Okay, this is the graph for electrical power. Based on the graph, the electrical power of the system suddenly rising, but then becomes stable after 3 seconds. It was suddenly increased because the load of the system increased. And then we will see the stability. Okay, based on the graph, the stability firstly rising when sudden increment was added, but then after 3 seconds, the circuit breaker operated and the system started to stable. Okay, that's all for sudden large increment of load at bus 7. Next, for the second case, which is sudden large decrement of load at bus 7, this is the simulation that we design using MATLAB software. There is also two areas, which is area 1 and area 2. For the system, the fault is set to start at 1 second and the circuit breaker used is normally closed. Besides that, 50% load decrement is placed at the system. Okay, firstly, for the result, there is also 3 graphs that we observe here, which is rotor angle graph, rotor speed graph, and voltage graph. From the rotor angle graph, the rotor angle of generator 1 and generator 2 was marginally unstable for about 5 seconds, while generator 3 is remain stable. Okay, next, based on the graph for rotor speed, the system is the speed of the system is increasing, and then for the voltage, the a spike of generator 1 and generator 2 occurred and it reached steady state after 5 seconds. Okay, next, for electrical power of the system, from the graph it shows that the system had small increment but then slowly start to decrease. Okay, last but not least, for the stability of the system, based on the graph we can see that the stability of the system firstly increase and then it slowly start to decrease. So that's all for the sudden large decrement of load at bus 7. Thank you.
Okay, hi, Assalamualaikum. So today I would like to present about temporary voltage 3-phase fault of bus 8. Okay, so before that, my name is Nordana Ahmad Siddiq, DE180150. Okay, so there is the model that I designed in MATLAB software. There's two of it, and area 1, area 2. So both of it we combine with the electrical circuit breaker in normally closed type. Okay, so at the below, there's 4 load attached with the machine. Alright, so let's move to the machine and we look for the graph first. Alright, okay, so there is rotor angle, rotor speed, PU, and voltage graph. Alright, so for rotor angle, there is first and second generator started at unstable mode and started to stable at second of 6, and then we move to rotor speed. Okay, so at the beginning the rotor speed started to increase and then they drop rapidly and then they increase, and at a certain moment of time it's increasing slowly. Alright, so we move to PU graph, and then it started to, at the beginning they are unstable and there's increment, at the above of the graph, and then at the bottom of the graph so increment but the decrease mode, and then the unstable mode at between 2 and 4 seconds, and then they started to stable. Alright, so for the voltage, there is unstable, so there is increment there, and then they started decreasing slowly, and at the second of 6 they started to stable. Alright, so next we move to machine signal. For the first one is electrical power. Alright, so this is the electrical power graph. So as we can see, there is instability of the system in form of electrical power. At the below of the graph, there's increment, decreasing, and then suddenly increase, and then at the between 3 to 2 until 4 there is instability, and then they started to stable at moment of 6 seconds. So we move to stability of the system. Alright, so as we can see at the graph, there is unstable. There is spark at the beginning, and then they decreasing slowly, and then this uprising there, and this increment at the above of the graph, and then they drop, and so at the second of 4 until 6 there is instability there, and at the moment of 6 they started to stable. So that's all from me. Thank you. Okay, hi, assalamualaikum. So continue to case 6. Okay, so here as we can see, same as before, there is same model designed in MATLAB. So there's 2 area 1 and area 2, and combined with circuit breaker, normally closed type, and then there's 4 load attached with the machine. Alright, so let's see the graph first. Alright, so here there's 4 graph. Alright, first is rotor angle, rotor speed, PU, and voltage. Alright, so at the first graph, which is first and second generator, seems like stable, and kind of really stable at second of 6, and then for third generator they're stable. Alright, so for rotor speed, there's increasing at the beginning, and then they started to stable. Okay, so at PU graph, there's unstable at first, and then they started to stable at 2 seconds, and then stable until the end of the time. And we move to voltage, and there's rising at first, and then they dropping slowly. Right, so we move to electrical power. Okay, let's go. So here is electrical power. At the beginning there is rising, and there's increment there, and then started to stable at second of 6, and then they drop slowly. Alright, so next we move to stability of the system, and here at the beginning they're rising, and then they are unstable at the value of 0.15. Alright, and then they slowly decreasing until the end of the time. So that's all from me. Thank you. There's for case 6 and case 5. Thank you.
As a conclusion, power system is divided into 3 subsystems, which is generation system, transmission line system, and distribution line system, where the electrical energy is generated, transferred, and distributed the load to the consumer. From this exercise, we are able to model a power system using MATLAB Simulink with SimSCAD Electrical, and from that we are learn the power system stability, where the power system stability can be defined as an ability of power system to regain its normal condition or synchronism after the disturbance occur in the system. And also from that we managed to analyze the dynamic response of the following disturbance in this exercise. And from that we are also able to work in group to solve the complex power system problem in group within limited amount of time by discuss how to solve the problem occur in the system so that the output graph can be obtained successfully. Okay.